Whoa, you swallowed a planet. That's probably what Henry's thinking whenever I eat my meal and he doesn't get anything. Hello, hello, welcome. Nobody seems to be here yet. I'm not sure if anybody's gonna join anytime soon because I know that Steve's streaming at the same time. We'll see, we'll see. Maybe somebody comes for a visit for some time. Yeah, not sure what Steve's doing, but we are definitely going to continue to fiddle with our Voron 0.2 in the Fysetc 0.2 r1 build variant here on Dirtling. I promised last time that I would be looking into some improvements of the sensorless homing and that I would also get some ABS prints done. Sadly, work had other plans, so I barely had time to play with the printer at all. There really wasn't much chance for it, so we'll have to do that on stream. I mean, I would much rather do it on stream anyways, since there are quite a few things coming up. There's also a configuration issue I desperately need to fix. Then we need to calibrate it and print something. You know the drill. I mean, we did that twice now. The only difference being that it's going to be done with a new material, but maybe we can find something else to do in the meantime. Or not. I don't mind either way. Let me get set up here. Things are a bit in disarray still, so let me at least, yeah, there we go. The stream, not Stream Deck, but my Stream Deck alternative is running finally as well. And Enik is finally calming down as well. He needs to get something to eat soon because we just got in from his walk. That didn't actually help the chaos. But the printer moved to its own location now. I have the mobile cam set up there. You can see through the glass that not much else changed, but yeah, it is there. We can use it. It found its semi-final resting place right there, aside from the Voron Trident, and yeah, looks quite pretty there, especially considering that there's also going to be a salad fork that's going to join it. That's going to be fun. That really is going to be fun. Oh. And now I can't get the camera to click back in. Well, I guess we got it. Yeah, so if you're new here, I guess you're gonna see this after the fact, so drop us a comment if you don't mind. Say hello in the comments, like, share, subscribe if you're so inclined. If not, then that's fine as well. But remember that anybody who is joining the stream will actually help it grow, because that's the only way that we get people here. And I am doing my utmost to make this somewhat fun and entertaining as well as educational. And I hope we can continue that. Cool. So let's not babble on too much and too long. Let's actually get into this right here. And I guess we want to start off by fixing one thing I completely got wrong during the setup of the printer. And that is that we're actually still using Stealth Chop, because I mixed up the way the parameters are usually defined. We don't want to save that. Let's reload that real quick, because yeah, I basically read the documentation wrong. What we actually want to do is disable Stealth Chop. I think we haven't done that yet. So let's check that out first. That would actually explain a few problems we already had with our prints, if we hadn't done that correctly. So let's check that real quick. Oh no, stealth drop is disabled here, here, there as well, and yeah. Okay, that's too bad. I was kind of thinking that was still on. That is too bad, because that would already have helped with a few problems. Okay, so I guess we need to look into other things then to fix our problems. Let's do a calibration of the sensorless homing. The way we're going to do that is we are going to, as it's actually described in the, oh, and wait, this is not showing you all the things I want you to see. So there you go. That's better. It is actually described well in the documentation. On this, no, this side. There we go. So what we basically want to do is, we already have a range, so we already know that sensorless is somewhat working for us. We are also hoping at the moment that our recent layer shifts were a result of the nozzle still getting struck or striking the bedsheet alignment screws. So we haven't actually verified that that is not happening anymore, and that we're not getting layer shifts anymore past the fact that we had some sensorless homing issues. And what we now want to do is we want to fine-tune the sensorless homing itself. The way you'd usually want to start that is by setting your drivers all the way to the maximum. So you can see it in the description here, setting your sensorless threshold to, or the stall guard threshold to 255 is basically its maximum, and then moving down from there, finding first the minimum at which point it works, and then moving on to the maximum at which point sensorless works. Now if we go to our slicer and our configuration, we'll see that there's already something set up here. This was already set up by Fysetc. And I think we're just going to set that to 255 again for X, and to 255 for Y. Save and restart that. And then we are going to use our console and our mobile cam to see what's going on if we try to home the individual axes. Now give me a sec here. I will actually set up a camera, or I will actually exchange the camera here. So you can see what is going on. Where do we do that? There we go. I'm just gonna move that there. Actually, I think we have a, and let me also real quick open the door on the printer. So you can see this better. And let's move it up for this experiment. So we can also see it better because it is now a bit of a ways away from my desk. So I will need to do this by camera. Oh, actually, I think we can, for that purpose, we should actually move it up all the way. There we go. And now, let me see if I have a base scene. That I can use. I should have prepared this, so sorry for that. But we can make it work. There we go. Pasting a reference there. And we're going to move that somewhere here. Make it a bit bigger. And add our mobile cam in here again. That's crooked, damn it. There we go, that's not better. Yes, that looks like it's not crooked anymore. Yeah, sorry, I'm fiddling around with the setup here. I'll be done in a second. There we go. That looks better. It ain't perfect, but let's see what we can make happen. We need our slicer, and we're going to add a scene. There we go. It's not all the way to scale, so please bear with me. Actually, I want. Sorry, OCD. Want to fix that. Need to fix that. Can't have that not be scale. Almost. Should be good. I would fiddle with this some more, but I also don't want to delay the actual stream. So let's get going here. Let's set this up. See what we can make happen. So there. And what we want to do now, as the description says, is we want to call the command that sets our stepper X to star guard to 255. So that's done. Now we also want to make sure we can hit the emergency button, and we're going to attempt to run G1028X0, which is the home command. And let me maybe pull up a camera here so I can better see what I'm doing. Because I only have it on the screen really small. I think that was too far, too quickly. I think I need to give it a bit more time. Restart the firmware. Let's try this again. I'm really not sure why these restarts always take so long. If anybody knows, please drop it in the comments. Please let me know what I can do to make these restarts faster, because on my Trident with the CM4, they work just fine. There we go. We're back. Let's go back to the console. Try that again. And this time it seems nothing happened. So, at least from that concept, we're good. Looks like we at least don't need to worry about it moving all the way to the other side and then hitting there. That's good. So we know that 255 doesn't do it. What we're going to do is, we also know from the Fysetc config we have been running that 100 is still a pretty safe value. So we're going to try 128. And 128 is too high. We can then go 114. That was very soft. So let's try 121. And let's move X back to the middle. What was that? G90 X 60. No, what was the move command? Let me see here. Oh yeah. G90, G91 is absolute versus relative. So G0 X 60. There we go. And we're trying 121. Wait. There we go. So the 121 is still too high. We had 14 work. Let's try 19. No, let's try 18. Also doesn't work. Let's try 16. Let's try 15. Also doesn't work. So 14, as we can see here, is our absolute minimum. Now we need to find the value that this doesn't stop properly anymore, that it crashes too hard. That's actually not as easy to do. I'm going to at least take out one of the earpods so I can get a better sense of what is going on there. We're going to set this to 100. We are going to move our tool head back to 60. And then we're going to home this. And that still sounds soft. So I'm going to go in 5s here. No, yeah. And it still stops soft. That sounded a bit less soft. And by the way, if you're wondering why, oh wait, let me see here right quick. Yeah, if you're wondering why this printer homes to the left, let me fix that real quick. It actually homes to the right, but the way that the scene is set up in OBS, it needs to be flipped horizontally. Oh no, that doesn't work. Give me a sec here. And let's flip that horizontally. There we go. That looks better. That is actually the correct orientation, so I will still have to use the wrong one, but at least you are seeing it correctly. We're in the middle, we're at 80 now. That is likely going to be a rather big crash because yeah, that is hitting too hard. So basically what we have now is we have a range of 80 to 114. We may be able to still figure out, let's use 83 here. Let's send it back. And let's home it again. Yeah, that's also too hard. 84. Guess we can just go 20. Oh, okay, that moved it further because we're using absolute and we're homing to the max. Oh, no matter. So we're gonna use 84 and we're going to home that. So that's the last least acceptable value, which means that we have a range of 84 to 114. Now to calculate where your sensorless homing value should be, you would take 114 minus 84, which is a range of 30, which means that half of 30, so I'm gonna take that. Divide that by 2, which gives us 15. And then we want to take our 84 plus 15 equals, in this case, 99. Which would be our ideal starting value for sensorless homing. Now, the better value is to shoot at slightly less. the middle is still going to give us somewhat inconsistent values, and at least as far as I heard it, you probably can't hear it as well as I do. I would guess that we can easily get away with, say, a 95. Well, so let's use that. 95 should give us in X a really good value, because it should be really consistent even with the temperatures currently being at the room temperature. That's something to look out for. Everything's going to expand a bit, so the whole printer might behave slightly different. If we notice that, then we can still adjust that. But for now, we're going to use 95 for X. Save that. The more interesting one will now be the calibration in Y, and for that I am tempted to adjust the camera to a position where we can better judge the Y. Although with the current setup that's a bit difficult. Yeah, this will have to do. Can't do too much about that. But at least we get somewhat of a good look, and I can still hear it. So, same deal. We want to that actually didn't sound all that healthy. Yeah, I think I don't like the way that already sounds. So I'm going to aim it at 97 here. There we go. Now for we may not be we're not connected yet. These reloads really take a long time. I am very much looking forward to a time when there's a proper CM4 in there, and the Victory Tag controller. That's going to be way better. It's going to be way better. But yeah, if you know why that is, why the homing is so, the reboot is so slow, please let me know. Okay. Why? We Oh, and that's taking a lot of... Let's move the printhead to the other side so we can see a bit more maybe of what's going on. Well, actually, I don't like that perspective very much, so I'm going to do something different here. I'm going to take my little camera, just put it on top here, although we may even be able to use a proper tripod for that. Let's see here. That could work. Now we're seeing the back of the printer, and I would want to also move this to 100 here. Just so we're closer. And then same deal. We need to set stepper Y, and we start at 128. That basically did nothing. So we're going to set this at 114. And our printer says homing failed due to printer shutdown. That does not look good. That does not look good. And these steppers, by the way, are already set to a slightly higher current than they were initially. So the X and Y are set to 1 amp run current and 0.6 amp hold, which if we reference the default config for the catalyst is 0.7 and 0.4, which is very conservative as we have seen, and setting them to 1 and 0.4, 0.6 actually worked to resolve some of the issues, but it looks like that's not all of them. And we are back. I'm gonna set this to 0.5 and this did home and it did not error out. So that's good. So we know that 105 works, but 114 doesn't. I'm tempted to set it to 110. Move our printhead out and try that again. And that actually did not fully home, so I'm guessing that 1.9 is going to be our minimum. Also didn't. Okay. Let's move this a bit out again. That went further. And this, by the way, could very well be responsible for the issues that we had, because these values look suspiciously low for the initial value that Fysetc set in their configuration. If they set it to 100 and we are already having problems at 107, that also kind of, or likely means that we will see sensorless homing working without bumping too much, bumping the back too much, until well into the 70s, and the actual value being more like in the 90s, I'm guessing. Okay, okay. So 105 might actually already be the sweet spot. 1.6. Let's see if it can do it reliably. I'm going to move that back. Okay. And yeah. So 106 is our upper end. And now we're going to go 95. Because we know 100 works. We're going to back it off here. And we're going to rehome that. That was completely acceptable. Going to try 90. Back it off. Interesting. That already hit quite hard. So let's use 92. Let's back it off. (92) still very soft. Back it off. So our range is between 91 to 106. And that leaves us with a difference of 14, which means that our actual middle of the range would be at it's 91 plus 7, because the range is 14. Well, actually, our range is 15. But let's be conservative here. 91 plus 7 would give us a 98 as a value. So already lower than what Fysetc had in their config. Now in this case, we also want to aim lower, but we need to be a bit more careful because we can see that this range is a lot smaller than it is supposed to, than it was with the x-axis. So I wouldn't want to go all that low. I would probably still try to go for 97. No, actually 95-ish. And put that in the config. And let's try that. Before we do though, I think it would be best if we back that off again, and also oh, and we didn't actually home X, so we can't move X off either. So let's go to our config. I liked how soft the x-axis still homed, so I'm going to try 96 here to see if that gives us a better value. And we said we wanted to use 96 here as well. Now we just need to wait for it to come up again, and then once that comes up, we can have a good look at the result and how that feels, how that sounds. Yeah. There we are. We're back, and X sounds fine. Y is a bit harsh. So I'm guessing 97 then. We need to wait for this to come up again. And by the way, this is why you do this with the console commands first, so you have a quicker way of moving things and don't need to actually reboot and reload the configs. But the fine-tuning you're probably always going to do in the configs, depending on like how the homing sounds. And I'm going to move Y off a bit and try this again. And that sounds perfectly fine. The only time that doesn't sound fine is if it's already in place, but everything else. All right. So let's see if that's reliable. The next thing we're going to do, and that's why we're doing this in the slicer, is we don't actually need to home that. It's going to take care of itself. But we are going to leave the values here. For reference, this printer had to be set to 96 on the stall-out threshold for the stepper X and 97 on the Y. So since like it looks like Fysetc picked a good bunch of default values, although they are slightly light. And I think one of the reasons why we had these homing fails that were still plaguing our calibration and the reliability of the printer is because they were just a couple of values out, a couple of values, meaning that if this does not trigger reliably, then you can have some weird things happen to your prints. Next thing we're going to do is we are going to print something, but we're not just printing anything. We are going to do the first ABS prints on this printer. For that, we need the extruder at temp to get our PLA out. And then we need ABS in. The question would be, what do we need to print? And the answer to that is, we, for example, need to print some new things for our ERCF. So we're going to mount a small leftover sample. Oh, and actually I do like that this is a leftover sample, but the problem with this sample specifically is that it is pop blue by Polymaker, and I really like the color. I mean, you can see it in a couple of prints. For example, one of the, I already printed some buffers and a couple other things, and you also know me that, or also know that I already printed some parts for the salad fork. And the thing is, I like the color. I really like how this color turns out. I like it every time. This is the, let's go here. This is the pop blue. It looks amazing in person. I'm pretty sure it also looks quite decent on camera. It's one of my favorite colors. They also have a pop pink that looks just as good, and I think both of these we will use to build the perfect bubblegum. This is just thrown together real quick. It's not calibrated, nothing. I will actually take this apart for the actual solid fork build, but this color and this color are two of my favorite colors from the whole range, because they're just so, they're just exactly what you expect from bubblegum. And obviously the cat ears had to be there, but the point is, these two colors are not available in Europe, which means that I had to order these from the US, from Amazon.com, and they were freaking expensive. So, to get back to the point, since that's the case, I am going to accept that an initial calibration will be a bit less exact if we use another material. But we're still going to use another material to do the initial ABS calibration, because I don't want to waste that filament. I really don't want to waste that filament. There's no good reason to. I am going to dismantle our construction here real quick. Go back to the slicer. There we go. And now I think we can take out our PLA filament. Might need a few more retractions. Whoa. One thing I'm, by the way, two things I'm, by the way, not a fan of, both of which I noticed during the week when I was playing printer, although I didn't have too much time, as I already elaborated on. The first thing being that the spool holder on the V0 is mounted in the back. That really sucks. It forces me to have it somewhat off the off the wall, which isn't exactly ideal. Okay. Now we need to, this is going to be a pain. I think we need to find another solution for that camera, because once the camera is there, I can't actually open the, oh wait, I can. Ooh. Oh yes, that works. The funny thing is I actually mounted the camera itself on a cupboard door, which means I can't swivel it away. It's such a weird setup. It is such a incredibly weird setup, but it has been working so far. All right, so we have our old filament out. We are going to use the Polymaker Teal to do the calibration, and then we're just going to rely on the Polymaker filaments to be hopefully reasonably consistent. But back to things I don't like. The other problem I had was with the Overture. No, what was it? It's not Overture. It is. Oh yeah, it is Overture Super PLA Plus. This has been printing really well. I have to say that. The print quality is reasonably good. It's not the best, but it is a decent material. But the quality of the winding on the spool is atrocious. I had it catch 3 times now, so purely from a reliability point of view, I really cannot recommend it. I'd really want to re-spool that, and I'm not sure if I can do a better job in spooling that correctly, but to be honest, I'm really spoiled from the spools that I received from Polymaker. By the way, all board, everything you see here is bought out of pocket. So no affiliates, nobody telling me what to say in any way. And yeah, one thing I can say that I really don't like is the Overture, the quality of the winding of the Overture PLA is really, really bad. Okay, and I think we can extrude some. Let's see if that actually... pulse and filament. And with that, this printer has printed its first ever ABS. I'm going to get that out very quick. I'm kind of curious to see what the how well the Nevermore is going to fare in that. It's going to be interesting to see how much of the ABS smell I'm going to get. Although to be honest, I do have an air purifier running almost right beside it, so that should also take care of some fumes. And I have windows open, although come to think of it, I can open one more. Yeah, and as usual, we can now, ooh, that thing is oozing. It is oozing. Now we're just going to assume that our z-axis is still fine. We can go into a new project and save the changes. Do some flow test calibration, I guess. Let's see what we can come up with. The first test we want to do here is a temperature tower. I already know that we're going to be in a range of, let's do 140 to 155. That's going to give us 4 levels. And 140. It's very rare that we need to print this harder than 155. Usually I tend to print it in at 150 or at 145. Gives really good results, still has really good layer adhesion. So let's slice that. In this case, we actually didn't need to adjust our first material because it is already set to ASA. Because we're finally printing in some real materials here. Yeah. Let's just give it a whirl, see what breaks. I'm very curious to see how long it will take this 24-volt bed to get up to temperature. Up till now, we have only run it at 60. But now it's time to also run it at 110. And I am really looking forward to seeing if the printer itself is actually reliable now. We did adjust the sensorless homing, so that should get rid of this first layer issue where we were only printing on half our print bed. We also adjusted the screws, which should take care of our layer shift issues, I'm hoping, but that might still be an issue. We may still be running this printer way too low, and well, actually I don't think it would very much surprise me if the currents that we're currently running are still too low. We'll need to see, but should the printer error out at some point, we can probably assume that we also may need to run a larger power supply. Not sure. We'll see. So the print bed's already somewhat struggling to get over the over the 70 degrees. So this is going to take considerably longer than the 60 degrees, which kind of a bummer. Kind of a bummer. I don't want to lie. I was kind of hoping that would be a bit faster, but it is only a 75 watts heated bed. So yeah, somewhat to be expected as well. And I mean, it's fine. It's fine. Let it take a couple minutes. We started at 9:13. We are barely 3 minutes in, so we're still at least as fast as a Bamboo on 110. And that is so there you go, Bamboo users. Although I'm seeing that curve, I'm not even sure it can do 110. The 110 degrees Celsius we set here. That's going to be interesting. It's going to be interesting. In theory, we can get away with 100 or 105, but it would be nice if we can do the 110, because that is, at least in my experience, the best temperature to run ABS on the heated bed, and it also is a good temperature to use for nylon, which I'm also very much looking forward to printing. One thing I will also do for reference is, I'm well aware that our chamber is not fully sealed. So I expect there to be some losses in temperature, but I am still curious to see how much and where our chamber temperature sits. The question is, how do I best test this? How do I sneak this cable in without creating a larger rift? And the answer is probably around the top head somewhere. We'll see. We'll see. The homing was successful, so that's good. But for some reason our slicer didn't do what we asked it to do. And there's Enik being reflected in the camera. try this again. And it looks like our bed is actually able to hit those numbers. I'm not sure why it slowed down earlier. But it seems to be able to hit the 110 degrees. But I do think we have a bit of a problem with our scripts here. I'll just try to print it again. And while it does that, we are going to look at the script real quick to see if we can find anything. What we know is that it doesn't actually execute the Z. And I think I know why. Because if we let's tell it to come up. Because we may still have some, actually let's try that. There may be a print macro that is actually trying to move the print bed that's all the way at the bottom to a position that is even further out. I'll need to check that. There might be something that that's introduced in Clipper in an older version, or that was introduced by Fysetc, or who knows? Who knows? Any script could be responsible for that. Even the XY homing script itself may be responsible for just setting the bed to the bed and print head to a location where then a relative offset is applied, and that could cause problems. Yeah, there we go. That was the actual problem. The homing didn't happen because for the homing to happen, there's a safe distance that is set up in the config. And if your bed is too low, then that safe distance is applied relative to the position of your bed and not absolutely. So yeah, there's definitely a problem we can figure out in the code. But first I want to see if it prints. We're heating up our extruder now. And what I am also going to do is I'm going to add some lighting to the printer because it is somewhat barely lit. Gonna use my little lighting hack here. These panels basically are powered by USB, and you can just lay them completely flat on your printer. It's kind of cool. Gives you all the lighting in there without even having LEDs. And no plans so far to add LEDs here. This is I do even have some, but I would rather use them on the solid fork, to be honest. There we go. And off we are. Let's see how that print works out. It looks clean so far. It looks clean so far, and it looks good. There are a couple inconsistencies, but in general, looks workable. But again, this being the first ABS ASA print, so who knows? The chamber from the outside, definitely not feeling as warm as I am used to with the Trident. But we'll have to see how that shapes up. And that should look better. Yeah, now we don't have this weird thing going over the screen. So there. The build plate's on a bit crooked though, which makes the whole thing look slightly angled. But so what? So what? We're good. We're good. So, since we already had Stealth Chop disabled and I wasn't as stupid as I thought I was, and since we now have Sensorless homing working, let's yeah, go a bit into the review of this printer. I'm going to set us up so you can watch this on the big screen, but I do want to put myself here as well. And let me quickly pull up my notes to see what we need to talk about here. So, what do I think about this printer kit? First of all, this is not going to be an exhaustive review. As you may already have realized, we're just doing the first ABS prints. There are still the endurance test to be done on how well this printer deals with the temperatures inside the chamber. I know that 3D Print SOS, for example, had issues with that on this specific kit. Yeah, so that's a bit of an issue. I don't know. I'm assuming that you can still get these. I'll still deliver the conclusion on the ABS printing and how reliable it is for that at a later date. I think what's important to discuss here is, first of all, was this printer worth it for me? What were the troubles I was facing? What is the difference between it and its successor, the v0.2 r1.1 kit from Fysetc? What are the differences? Maybe go into a bit on what may be better, what may be worse. Also, is it worth the extra money you're going to spend on the new kit? For example, to get the updated version of the Catalyst board? Or is it worth actually getting this kit and then modding it to what you want to do? There are a couple of trains of thought here, and the quality of the included components may play some role in that. We also need to go into some inconsistencies and some, I would say, amendments to the manual I would like to see. And yeah, finally draw our conclusion on whether this kit can be recommended or not. The other thing I want to point out here though is that I don't necessarily will go into whether this kit can be recommended on a general level. What I will instead say or state is who this printer kit could be for. Because I think that's the better question and the better approach, I would say. But I see this print already shaping up quite well. I don't like the bottom layer there, but otherwise, from a consistency point of view, I kind of like that. I kind of like that. There's some stringing to be seen, so we may need to adjust the retractions. But this is also the 255 degree Celsius print, so I guess this was to be expected. I would expect it to be way less or even gone on the 250 and definitely gone on the 245. Anyways, continuing with the printer kit. So first of all, a general account of this printer kit. The build was fun. It cost me 340 euros to acquire, which is probably 260, 270-ish in Yankee dollars. I also spent about $5 on the supply of ring terminals we used to modify and fix the electronics. And I spent about $20 on fans because I already know and knew that Fysetc fans are not built to last. That's important to note because there's currently one fan in there that is under review. We'll need to see how well that holds up, but speaking from experience, in my Trident I already had fans that failed after only a month of use, and that caused prints with bridges and with overhangs to look really ridiculously bad, to the point of being unusable and being a waste of filament in itself. So one thing I would like to be able to do is replace the fans on these printers. We'll need to talk about whether that actually makes sense in this kit, because there are a couple of hurdles to that. But in general, yeah, that's the cost. The fans for the print cooling are exchanged, so those are already new and replaced, but the fan for the hot end itself is still original. So from the overall $265, I think we already included $260 in this printer. The printer is functional, as you can see on the screen. It does work. There are certainly still things to calibrate. You can see the curling on the print there. Not exactly the best thing. It is really fast. It works really well when it works, but there are a couple of issues. What's also cool about this printer is the upgrade path, because while you don't necessarily need to upgrade anything initially, the hot end mounts into the same 4 screws that a Dragon hot end mounts to, or the Creality Spider V3, which we currently have in here. The Spider V3 has a slightly different mount though, so while you can make it work with the Dragon hot end mount, I think you're losing a bit of Z height if you do, so it's not recommended. But in general, the upgrade path to a bigger, higher flow hot end, very much there, and very much appreciated. Not only that, but you're also getting cheap components of whatever you would want to replace. For example, if you want to replace the catalyst at some point, you can totally do that. Cool is also the CNC gantry and the bed mount, both of which the CNC gantry we haven't installed yet, but the bed mount seems to be really solid. The first layer is going down really well. We don't have to adjust much, if anything. Well, actually, the simple truth is that up until now I have yet to adjust the to readjust the bed once. There were also some thumb screws included that would replace the yellow thumb screws that we are currently using. You can barely see it, but at the bottom in the center you can see a yellow thumb screw. I didn't actually use those because I wanted the yellow one, but they're there and they're probably working really, really well. Really well. So definitely like that. There's also a bunch of spares included in the kit, so I did not run out of anything. I thought I would because of a mod we already did, but we didn't. So there's enough spares even of the let's look at it. I mean, there's really more than enough here. We can easily go to the top cam. We've got a full roll of VHB tape. I now have 3 printers and 3 rolls of VHB tape. We have quite a few by 16s, by 35s. That's actually not something. We got additional connectors. The one thing I ran out of because of shenanigans with the printers were the M3 by something's mucked up here. Were the headers for the smaller tool head connectors. The Catalyst tool head uses the PH JST connectors, not the XH, which means they have a pin distance of only 2 millimeters instead of 2.5. And I didn't have any of that to hand, but if you're just installing everything and you're using the pre-crimped wires, you're not going to run into this problem. Like even the self-tappers, we have enough, although the mod we did, for example, one mod we already did is the filament sensor in the tool head itself. We have 3x40s, by the way. These really interesting for builds for the stealth burner as well. Standoffs, I really like those standoffs because they are way more stable than the printed ones that you're supposed to use. The printed ones are just ridiculous. Yeah, M3x8s, we have a ridiculous amount of extra screws. So from what you have here, everything that you have here in additional M2 nuts, additional M3 nuts, I mean, it's more than enough. It's more than enough. It's enough so you have hardware left to build yourself a Nevermore, as long as you get the activated charcoal and some proper fans. Do not get a kit from Fysetc. Just buy the Sunon fans. Buy Sunon fans, put those in there. 13 cubic meters per hour, I think, of throughput. Works really well. Works really, really well. Yeah, there's enough stuff left here. Even the ECAS 4mm fittings, pins, it's all there. It's all there. So yeah, spares more than enough. The tool head spacers, all good, like that. So yeah. What I also like is that if you're not looking to immediately modify your printer, to immediately use different electronics, the Catalyst board is actually that simple to set up. all the wiring is included, everything's there. You just put it on the board. We can go to the web browser. The wiring diagram is well done. It shows you exactly where things connect. No problems whatsoever. No problems whatsoever. Yeah. So that's what I like, and it's working. It's a working printer for like about $100 more than a Sovo SV06. That's already like this is cheaper than the Two Trees. What was it? SU? I don't know. There's a Two Trees 3D printer. Let's look it up real quick. Yeah, the SKT. The Two Trees SKT usually around $400. This one, let's go back here. This one, $340. Now that's cool. That's cool. I also like that it is in general a small printer, and the reason why I like this printer to be small is because it uses less power. It heats up faster. It is safer in the sense that you're not running a mains bed, which is both safer for your for your aluminum heated bed, as well as because it heats up slower and therefore doesn't cause as many thermal stresses, as well as for you, because if anything happens to it, it is safe to touch. At least from an electrical point of view. At least it's very much lower risk than an AC bed. That's just, I prefer DC beds, to be honest, even if they take a bit longer. And if we compare this to the Voron Trident that I'm also using, you just saw it heating up. The heat up time of this printer was around 5 to 6 minutes. That is just fine, and with those 5 to 6 minutes, this small printer will actually already be reasonably well soaked. It's not going to be fully at temperature, but it's reasonably well soaked, and to be honest, it feels like there's considerable temperature in there, so really no problems whatsoever with how this thing is built. The question of the day, by the way, I'm going to also hook in the temperature sensor here real quick to see what the temperature inside is. That's actually pretty decent. We currently, on the front, we already have a pretty good temperature of 42 degrees, and that's probably not even capturing the high temp that we have further in the middle. See if we can capture that. Yeah, I so like this. This is really good. This printer is already soaked to almost 50 degrees. Actually, it might as well be. I think it's already at 50. and potentially beyond. So yeah, yes it is. It's actually well below, above 50, so I'm going to remove the temperature probe here. That is impressive. That is impressive. It looks like it's holding together really well. Even though I am skeptical about those magnets and a couple of other things that I would want to replace, but it's working. It's working. So from a functionality point of view, from a point of view of did I get a printer that I can work with, it looks like we're good. It looks like we're exactly where we want it to be. Now, the flip side of that is, what did we do or need to do, need to be able to do, need to be aware of, and where did we lose time in getting there? And that's, I think, where this printer has a few problems. One of the problems we ran into during our first couple of prints was the silicon sock that was supplied. So, and this is one of the trip-ups we had. This is going to be a bit of a summary of the trip-ups we encountered. But essentially, let me move this aside. This silicon sock and this additional cover of the nozzle for on the silicon sock is too deep. So it did catch on a print, pull itself crooked, and then have this print inside this. And at the same time, obviously, since now the plastic was flowing around the hot end and not away from it anymore, ruined a whole hot end. Damage of this, and that's to be kept in mind, was about $10 because obviously I was careless and I should have monitored a little bit more, but B, this can happen at any point in time, right? Even once you have your printer in a trustworthy state where you're just not monitoring it anymore, this can still happen. And when it happens, you're gonna have a bad time. You're gonna replace that sock and that hot end, that heater block at least once. Damage of that is an additional, I think $12, I think. You can lower that by buying a new sock immediately. If you see that, you're probably still at $5. The next thing I didn't like, and we already accounted for the cost of that, are that there were fork terminals used. Fork terminals are a problem because even if you clamp them down all the way tight, screws can shake loose. And screws shaking loose can be a major issue if you rely on those forks. If you instead use ring terminals, then you have way less of a chance of those ring terminals coming loose because the screw is actually holding them in place tightly. And because that's the case, ring terminals are considerably safer, especially in a printer that is vibrating. So while many, and this by the way I think even goes for supposedly higher quality manufacturers like LDO, which by the way is still a Chinese manufacturer, right? We're not getting away from Chinese manufacturers, but even though they're used by many manufacturers. They should be ring terminals. Really, they should be. It's a safety concern, and having ring terminals instead of the forks going to your power supply and going on the high current lines between your power supply and your controller board is to be preferred. This also results in you not, like, if you really want to do this right, if you really want to fix this, that you need the M4 red connectors. And if you really want to do this correctly, if you really want to have your printer be safe, at least part of the wiring harness that Fysetcs so well crimped for you now needs to be recrimped with at least, what's it, 4 and 3 makes 7 connectors. So that's a concern. That is a concern. You will not be able to use the wiring harness as it is. Keeping with the wiring harness, there are 2 more problems that I have here. For one, we encountered this a couple of times during the build. The cables are too short. There could have easily been a couple centimeters extra in the cable length. So we encountered this, for example, when we were mounting the Z motor. The Voron manual actually says that Z motor should not have an orientation applied. And because it should not have an orientation applied, I was expecting that to be that the orientation shouldn't basically matter. So I turned it to have the wire come out to the front instead of the back of the printer, which would have resulted in it lying flatter on the surface of the controller board mount and moving to it, instead of having this big bow and then going in a bow to the controller board. Sadly, the Z motor wire is not long enough to do that. So we had to disassemble our printer. We had to make sure that the wire, the connector for that wire on the Z motor is pointing in the direction of the IDEC inlet and to the back of the printer. That's the only orientation that really works with that short wire. The same thing we had happen, and that was truly my fault, but we could have still had longer wires there, was with the power supply IDC inlet wires. I guess that was fine, but the third and still unsolved problem is with the cable, with the bus cable for our display, because that is also too short. So you can actually not route this along the edges of the printer to your mainboard. You have to route it across and over the mainboard, and that can cause issues with interference generated from the power supply if the power supply is not of good quality. And that's something to keep in mind here, by the way, in general. Just because I got a working printer out of it doesn't mean you're going to get exactly the same quality. These printers, while Fysetc has systemized it somewhat and is ordering parts in specified quality, does not mean that every single printer will give you the same result. Yeah. There's another problem with this printer. It is that it does not support LEDs on the toolhead. So they're also not in this kit. If you want to have LEDs on the toolhead, you're going to have to add that support yourself. It's pretty easy to do. There are enough possibilities still open for you to do so using the catalyst board and running one single additional wire to the tool head. But yeah, it's something you need to take care of yourself. It's definitely something you need to take care of yourself. And this is where we get into a differentiation between the new and the old kit. The new kit includes a new controller board and a new toolhead board. And that does contain the LEDs. Yeah, okay, so those were the problems with the wiring. There's one additional problem with the wiring that your opinion may differ or may vary on, is that there is no earthing provided whatsoever. And while I know that some countries, including the US, have no explicit rules about earthing your products, in the EU at least, or any country that adheres to the CE and requires the CE marking, your devices need to be earthed. The reason for that is that if anything goes wrong, and that does not just have to be your power supply blowing up, it can be basically anything. You want to have any mains voltage routed to the earth terminal, and not through your body, because if your frame, if your housing ever starts carrying current, the current would run through your body if there wasn't proper earthing provided. It's just as simple as that. Yeah, so that's one of the issues that you will need to deal with, if you're so inclined. Right? Nobody says that you will want to do that, but I would certainly strongly suggest you do, because it's just much safer. And I would actually want to see this accounted for in both on both the Voron team side as well as the side of kit makers, because it's the safer thing to do. The cost, the additional cost you will incur there, is about $5 at most for the hardware. You basically need two serrated washers, one or two serrated washers, and a junction. Then you just clip your earth cable that's coming from the IDC in half at the junction it to a point on the frame where you previously removed the anodization, or use the serrated washers to do so. So those approaches do work. Yeah. What I also don't like about this printer kit, but that's more of a minor issue, is the point that there's no stainless hardware included. This may not matter to anybody in less humid areas, and to be honest, it doesn't really matter where I am, but it will matter to anybody in more humid climates. And in those areas, I think you're gonna want to use stainless hardware to begin with, but you may also need to use stainless rails, and I am not sure these are. That's something I haven't checked. Yeah, another major issue with this kit is the position of the thermal fuse. I don't think it's located in a good position, a safe position, because it if you watch the earlier videos, you will see that it only touches the very rim of the heated bed and is therefore not actually measuring the temperature of the bed accurately in any way. And that's a problem, because that's your safety against thermal runaway of your bed and your bed overheating. So yeah, the reason why that's important is because that is not the only thermal fuse. There's a second thermal fuse in the bed, but if that internal fuse breaks, it does not reconnect. I think it's a burn once and done fuse, so you want to protect that by an external one. So your external one goes first, and you can then just replace the external one. The internal fuse is still fine, but if your external fuse is located as badly as it is here, you may end up having to buy a new bed. And by the way, those beds are somewhat custom. They have custom cutouts, and they're scaled custom. Well, actually, custom cutouts not so much, but they're scaled in a custom way. I have another 75 watt heated bed that would not fit this printer bed. So there are a few things to look out for. Yeah. Further minor parts are, for example, the inclusion of a blue PTFE tube. Really don't like that. It does not mesh well with quite a few color combinations, so a clear one would have been appreciated. The anodization I found is somewhat fragile. My printer already has a couple of nicks. I don't mind. I don't care. It's a tool, so it having nicks actually shows some age, shows some character. But if you care about your printer and how it looks, you're definitely not going to enjoy that much. Yeah. Moving on to electronics. So you heard me say earlier that I do like the Catalyst board for its simplicity. There's a flip side to that. There are crucial customizations missing. One of those is a fan voltage selection for the hot end and printed parts fans. The reason why that's important is because you're not just going to run these fans. Especially with the quality of the fans included, you can expect to have to replace them. And the way you're set up here is that you need to decide between 5 and 24 volts. Basically for all the fans. Every single fan in your printer needs to match that. You also have the option to use 12 volt, but like you need to decide. And if you find a good fan that is 5 volt for your hot end, and you find a good fan that is 12 volt for your parts cooling, you're not going to be able to use that. You will need to match both fans with the fan voltage. So some restrictions apply, and these are actually restrictions that matter, because the only like the best hot end fan from Sunon is actually a 5 volt fan. It's really good, it's really strong, but it's 5 volt. Now the best 3010 blower fans from Sunon are actually not really good. Well, they don't even offer 5 volt 3010s. They offer 12 volt, I think. Or you can use the ones that we have in here right now, the GD-Stain 24 volt, but there's a discrepancy here. There's a simple discrepancy in that our printer is supposed to run one single fan voltage, and that's going to give you restrictions that that will make your choices harder to find proper upgrade parts. There is a way out of this. There are still like 5 volt 3010s that Sunon makes for your part cooling blowers. The problem with those is that they're 20 bucks a pop, and that means that you would pay an extra 40 bucks for your cooling solution, which is just about the price, now we're getting into upgrading, that you would pay for an EBB36. Well, actually the EBB36 would be way cheaper because you only pay 12 bucks for those, but your SHT36 from Mellow, the EBB36 being the same thing from Picturetech, but bit of a different layout, bit of a different feature set. The SB, not SB, the SHT36, the Mellow variant with the arguably better connector, but otherwise functionally equivalent. It's the same or even cheaper price, and both boards have the ability to select the voltage independently for both fan groups, and they then also support the hot end LEDs. Now those boards get connected via CAN bus, and because they're connected using CAN bus, they're let's leave that cooling for a moment. Because they're connected through CAN bus, you would need a connector on the board. The good news is that the Catalyst does support that, so you can easily exchange the existing toolhead board for 12 or 13 bucks even for a EBB36. All right. So that's pretty cool that you can do that, but you need to do it if you want to have your printer working reliably for a longer time. The second problem that I had with the Catalyst boards, and this actually doesn't necessarily pertain to the board itself, but to the software that is installed on the boards, is that the pressure advance and the input shaper values that are delivered by default are just plain wrong. They're wrong. They caused a lot of issues. The pressure advance value was way too high at I think 0.25 or something ish, which there was just a zero missing behind the decimal point to make that in any way remotely where it needed to be, and it causes the first prints to come out ugly. Also, input shaper is defined by default. And the reason why that matters, or why that is not a good idea, is because you haven't even tested the input shaper. Your resonances will be somewhere completely different. And if you don't hit those resonances right, you're actually going to receive smoothing of your print or bad results. So while those catalyst boards, or the catalyst board itself, worked properly, there's like the software in those needs to be replaced. The last problem that I had with the catalyst board, or rather the motor drivers, was the fact that it did not come with a with heat sinks for the drivers. These were supposed to be in the package, but they weren't. And because they weren't, that is another couple of bucks that you will need to account for when buying this kit. Let's say they're $5 or something, just for later. Yeah, so those were the problems with the heatsink or heatsinks. There's also a problem with the print sheet alignment screws. Those are too long. Those need to be shimmed. You can also grind them down. I wouldn't grind down anything inside my printer, so please do that before you put them in. But shims work just fine. You just don't want them to look up anywhere further than 0.1 centimeters past your print sheet. Otherwise the nozzle is going to catch on those, hit those, and cause layer shifts. Also then potentially damage your potentially damaging your like mounting points for the print head itself. Ideally, you can find some M3x13s or and M3x9s, although those are pretty special sizes. So just shimming for 1 millimeter to 1.5 millimeters should work out pretty well. What's a bit problematic there, and this is something you really need to look out for when you're building already, is that you cannot do this after the fact. You cannot access the screws again after the fact. And this brings us to the instructions. One thing that's missing in those instructions is the explicit hint that these screws should not peek out behind the print sheet past its height. So that's something that Fysetcs really needs to add amendments to this manual to account for that. The other things that were missing in the manual, as you may have seen in the build previously, is the alignment of the Z motor. Again, cable too short. We already talked about that. That needs to go in there. And there is also no mention or proper guidance on how to mount the catalyst board and the electronics fan properly. Ooh, that is on there. That is so on there. I like that. We are going to leave this cooling down here for a bit. Yeah, other things that are missing in the manual are, for example, how to mount the toolhead board cover, although I would strongly suggest not mounting that because it may lead to cooling issues. And because we're missing mounting information for the catalyst board, we are also missing mounting information for the backplate that the catalyst board is mounted on, which the instructions from the Voron team have you include a couple of extra screws. They actually want you to include 4 screws there, but to properly mount the catalyst board backing, you only need 3. So those are things to look out for when you're building this printer. There are videos. The videos are showing how to build this printer, except for the part for the catalyst board. The problem with those videos, and I think that's also something that Fysetc will need to fix in future revisions, is that these are AI dubbed, and they're not even well AI dubbed. There's vendors out there now that can give you really good quality of AI dubs and make it so you can really well understand those videos. But since they are referencing technical values, which these AIs have in the past not dealt with properly, and because of the way that this is pronounced, then makes it really hard to understand what hardware to actually use. So these videos really are not, I cannot stress this enough. These videos are not a good source of information for your build. There should at least be clear hints on where those where edge cases are and how to deal with those edge cases in a proper manual. I think LDO does this. I've never built a kit by them, so I'm not 100% sure, but I think LDO actually provides something like that. And yeah, just have this done real quick. It's not actually that much. Yeah. Some more stuff that kind of I don't like, but that's generally okay, that I'm not worried about as much as, for example, electronic safety and upgradability, is that the bed connection uses Wago mounts. I would have liked to see some cables routed straight through, because there is no value added by having Wago mounts there. It would be way better if the cable would just go right to the controller board. Done. Not sure why those Wagos were added. The Trident, for example, does this for the heated bed power supply, but interestingly enough, not for the sensing. Not for this thermistor. So I'm not sure what the intention was here, but these Wagos only make sense to me if they kind of look like a wank feature. They would make sense to me if there was any reason to be able to quick connect and disconnect the heated bed. But why would you? This is a 120 by 120 by 120 millimeters printer. There's literally no reason why you would exchange that bed. Like you'd expect that to be in there and done. Now the reason why I care is because those Wago mounts are a source of trouble. in general, they are reliable, and I don't have too many qualms about them, but a cable straight to the back of the printer would be much better, especially, and this is something to keep in mind, especially since that cable is usually what would break anyways. So I don't see too much of an issue with having that go straight through. It's the same way. It's done the same way on the Fysetc Trident kit. So not sure why they went fancy here. It's the cost at no extra reliability. I do have to say that the result of this is nice though, because it is reasonably clean. Yeah, so those are my major gripes. One other concern I personally have, because I am working in my personal network here, and I'm also using the same network professionally, is the security of this printer and the fact that it is not using an off-the-shelf unmodified version of the of Linux. It is using a Linux that is made for the what are they called? Rock chip SoCs, but it is modified by Fysetc. Now, why am I concerned about that? The reason is because any company, any Chinese company, is required by law to, in any event and under any circumstances, be able to support the CCP with information and answers. Now, that also requires the companies, Chinese companies, to include in their software ways to gain that information, which obviously is concerning for me from on a professional level, because that would mean that in theory, without even needing or being required to mention it, the CCP would be required to have some kind of backdoor access to this printer, and that obviously is a no-go. Whether they actually do that or not, I have no idea. I can only speculate about that. But it is something I am concerned about and something to keep in mind. Having a look at the print results here real quick. I am going to use a... Oh, let's use this to see if we can break these easily. Yeah, that broke. That broke as well. Quite easily. Quite easily. Yeah, so there's almost no difference between the 140 and 155. The 155 print does have more stringing. Stringing gets increasingly good the further up we go. You can see it here. I don't mind the stringing we see on the 50. If I wanted a really stringless print, I could go 145, but 150 is just fine. What we also need to check here is the max flow rate. And we're going to create a new project for that, just so we don't take along any of the old settings. Remember, we had a problem with that before. Just making sure that that's all fine. Let's actually run a retraction test. I think we can go 0 to 1. Slice that and print it. And yeah, just go. Anyways, those are my major concerns. If you're in a situation where you are really concerned about the Catalyst board and its security, the definite recommendation is go with a vendor that lets you bring your own MCU. So what I'm talking about there is, if you're really concerned about not having any Chinese influenced hardware in your network, then your choices are basically Bigtree, Mellow, or LDO. The LDO toolhead board and, well, actually the toolhead board and the mainboard don't have much to do with that, but the LDO mainboard, the Leviathan mainboard that is, relies on a proper Raspberry Pi 4, 5, 3B, whatever have you, even the 0.2. To provide an actual controller, which in either case would result in you using a controller that you can use a Raspberry Pi OS that's open source, that's controlled, that's installed by you. So that's definitely an option. Or use the, and by the way, the same goes for the Mellow boards and the Bigtree boards that do not come with a slot for a module on board. The ones that come with a module slot on board are basically just as good, because you still bring your own Raspberry Pi. What I wouldn't do in those cases is then rely on a CB1 from Bigtree, because the Bigtree CB1s still run on a similar open source solution from Bigtree itself, instead of using a proper open source OS. So that's not to be recommended in those cases. If you don't care, go crazy with the Catalyst, because it is that simple. It really is that simple, and from a results point of view, very much appreciated. Even from the point of view that you can just pop in a $13 EVP36 there and have that run, and then get CAN bus. So no problem whatsoever. No problem whatsoever. I actually like that. Going over this specific review though, and this is something I want to highlight because remember we initially started with a $340 printer plus $5 ring terminals plus $20 fan. But if you're also accounting for the fact that you will destroy at least one heater block and stock, if you don't replace it, that's another $5. And the fact that if you want LED lighting and better replaceability of fans, better the flexibility of being able to replace your fans, you also need an EBB36. And you also need heat sinks. We are at 65, 80, $390 for the kit with a more or less perfect starter set. With a really good starter set. It's not going to be all the way perfect, but it's a really good starter set. It can take you places. Now, how does that compare? And by the way, if you want to buy one of these kits, this is probably the other thing, because if we look at AliExpress, and let me pull it up here real quick. And let's go to the browser here. If we just pull up the V0 kits here, we see the current prices and that there is more or less a consensus that puts the V0.2 R1, and let's maybe sort this by price, and we're gonna go top down here. So the differentiation between the new and the old kit is basically, this is the old kit. You see the light gray background, you see the catalyst board, and you see it being called R1. This is the 1.1 kit, definitely distinguishable by the hot end that's used and a couple other things. This is also an R1 kit. We're basically going into the area of this is the cheapest R1 kit with a 374 euros price tag and an additional discount of $25, which means that this kit at the moment is to be had at $350. That's $10 above what I paid for the kit when it was still the top choice on the market. Now, what does that look like for the new kit? The new kit this is also an r1.1 kit, an R1 kit. These are all R1. Some of these are Voron kits, so they're not the Fysetc one. The cheapest kit, at least for me, including shipping, and shipping is a concern here, right? Because the printer we had here has $35 of shipping, and sometimes is to be had at even lower, which is, by the way, something you should definitely wait for. Wait for special occasions, special Chinese locations like Chinese New Year, like the 11th of November. They do something for Christmas as well, for Black Friday as well, but 11th of November, definitely a big one. Chinese New Year, definitely a big one. Look up the Chinese holidays. Those will net you the biggest discounts if you want one of these. With shipping here, we're talking $385. And there's definitely still some discount to be had. We're not looking at the Blue World stuff. Our cheapest option for the 1.1 kit is $100 more expensive. Now we need to talk about three things. The first thing is new kit or old kit. And for that we need to look at what the new kit does better and whether that actually matters to us, whether that actually makes a difference to us in terms of additional features. Now let's quickly go over the upgrades. The first upgrade is that they actually increased the height of the top cover. That's a good change because it does make it so your filament hose and your cabling rubs on the top head way less. That's a good change. It's not something that's ultimately significant, but if you were to want to do that yourself, you would still pay about $20 for the upgrade. Let's put that maybe together. So that would be 20 for the higher top head. I personally don't value that change all that much, but it is also a change that you can very easily do. Well, actually, it's not quite true because you don't just need the extrusions, but you also need the panels. So if you were to want to upgrade this later, I think you might even be looking at $40. The question is, would you want to? The second thing that is different is the Catalyst board V2 with a more interesting lighter cabling solution and the tool head board. Now I'm going to be really pragmatic here, and I'm going to assume we get away with the V1 board and an EBB36. The nozzle LEDs that are included are about $4. The new sailfish hardened I can't say anything about. And the newer gears here, I'm not sure about. So those are definitely I would say interesting choices. The blue PTFE tube I value at about $5. That's the amount of PTFE tube or the cost that you need to account for replacing it. But that's a replacement I would personally do anyways, no matter whether you buy the old or the new one, the old or the new kit. And the Z motor. Let's assume that's a $15 motor. That's a pretty good change. That's a pretty significant change. So the question marks here are the sailfish hardened, by the way, which has already shown itself to be somewhat untrustworthy, and that some people already went and replaced by a bamboo hardened, and a bamboo hardened conservatively $35. But a bamboo hardened is going to be more reliable than anything that Fysetc produced here, I would guess. Just the way it is. Just the way I figured. So let's value that bamboo hardened at $35, and the palm gears, let's put them down at $25, I think. That's actually quite the fair value for those, or actually quite the high value, to be honest. I think I got mine for less. So all in all, that gives us 75, 80, 120, about $140 in upgrade parts. So that means that if you were to buy the kit right now, you would basically save yourself about $40 in upgrades. Ish. Because you would still very likely incur the $35 of cost for the bamboo hardened if your sailfish hardened doesn't make it. If the sailfish hardened doesn't hold up, you are still going to incur the $5 of PTFE tube, very likely, at least because the color doesn't match your printer. Oh, I forgot something. The stainless steel rail. And this rail, by the way, is also, I think, milled out. So what's that, $30? So all in all, pretty good value proposition. Probably better to look into the new kit first. But, and this is really important, no matter whether you choose to buy the R1 kit or the r1.1 kit, you need to be aware of the fact that the quality of the components, it is a Chinese kit, will always be somewhat questionable. So the first question I would ask yourself is, do I have the budget for an LDO kit? If you have the budget for an LDO kit, you will, for the increased price, definitely get a printer that will be more reliable and will be a better build experience than what you get here. By how much is a good question. I can't answer that, but you will definitely get a better experience. We can actually assume that let's look it up. Let's look it up. Let's ask Google about shopping. Sorry for the German version. So here we're paying about $250 extra for a better, more reliable print experience, for the better rails. And let's make a list of what we would need to upgrade for this printer to be equivalent to the or to upgrade our Fysetc kit to this printer. We would need to upgrade the rails, probably all of them, which is just about $100. We would need to upgrade all the motors, which is another $100. We would definitely need to upgrade the fans, which is another 20. So we're already talking about at least $220 extra investment. If you wanted to upgrade your Fysetc kit to something that is close to the LDO kit. So if, and I stress that, if you are a beginner to intermediate, well, actually beginner mostly, builder of 3D printers, I would suggest going with an LDO kit first. It has way less issues that you need to be aware of and that you need to be able to debug and fix that can potentially stall your progress or even result in you having a completely bad time. And it will therefore be a more fulfilling experience. That being said, I would not recommend this printer build as the first printer to anyone who is a beginner, because of the fact that it is built on 1515 extrusions, and there are a bunch of things that come along with it in terms of planning and understanding how a printer is built, how a printer works, that I think having a printer based on 2020 extrusions and building that as a first printer is generally a better idea to begin with. So Trident 25, for example, really solid build. Would definitely suggest, if you want to start building printers, do not pick up this one, do not pick up an LDO kit. Pick up, of the 0.1, pick up an LDO kit of a Voron Trident 250. Because that's the safest route to you getting a properly working printer. The safest, most reliable route. If you don't mind some hardship, as a beginner, as a bloody noob, then go with a Trident kit by Fysetc, or by Voron. Pricing is going to be the same. You're still going to look at something like I don't know, $600-700 at least. The Fysetc kits can be had at 500 or below, so you'll just need to have to see, but it's definitely in the range of a LDO v0.2 build, and it's definitely the better choice for building your first printer. Now, for your second printer, you should already know how to build a printer in the first place. The LDO kits are still going to provide you a better build experience. They will require you to do less crimping. They will have the extra cable length that you need to be able to make mistakes or to do things custom the way you want. They will have the safer inlet. Although that's included, by the way, that's also something I think that's true for this kit now, for the new V0 kit. Let me write that down real quick. So in general, you beginner, 250 Trident, Voron or LDO. Second printer build. Now it doesn't matter as much. LDO kit's still going to be the easier, better experience, the less challenging experience, I should say. Doesn't necessarily need to be better. But if you just want a cheap second printer that heats up way faster than that oversized monster of your Trident, which, by the way, will take 15 to 30 minutes to heat up before you can print anything on it, which is a pain in the ass. It basically doubles your print time on most smaller parts. It's kind of insane. But second printer, and you really don't mind hardships in the build experience, then these Fysetc kits are just fine. You need to be capable of already making your own decisions and determining your own additional actions that, for example, were outlined here. Like how you need to be able to make your own decisions on how you need to earth your printer, on what you need to fix, the bed screw, the bed sheet alignment screws, and so on. All that is important, and you need to make up your own mind on those, because the kit is incomplete. As I would consider it very much incomplete at this point, because these problems are still persisting. But in general, already a solid option. Now, if you're a pro and you build printers just to build printers, you don't print with them too much, but you enjoy the experience of printing, of building, and getting them to work, then this kit is fantastic. Because using this kit and not paying an additional $100 to $200 for an LDO kit actually enables you to easier buy the next kit. And the build experience of this printer, especially if you're looking for builds, which I'm guessing you're looking for some adversity at least, that's really invaluable. So pro builder, definitely go with these. Don't expect too much in terms of quality from the rails. You will need to mod it. You will need to deal with a couple different things to get this printer to do what you want it to do. But all in all, you will end up with a working printer if you take your time and do it well. So for high mid-level to expert builders and hobbyist builders, like who really are in it for the build itself, I can totally see how this would be a better choice than an LDO kit, just because it still results in a working and reasonably well and reliably working printer, even though it's like $200 to $300 cheaper than the higher quality kit. So definitely recommend it for people who are more intermediate to expert and looking for a build, not necessarily a long-term ultra reliable printer. That being said, I think the new kit is not a good choice for those people, because you're looking to build a cheap printer. You're looking to build a really cheap printer, and the additional height of the top cover, the tool head board that you can just as well achieve with a $13 EBB36, the LEDs that they're in themselves they're $4, and if you're going for the EBB36 anyways, right, like you don't have a problem here. The rails are working just fine in the kit. You don't need the newer rails. The old hot end is working fine, but the reality is that you likely will need to replace it by a bamboo hot end anyways, or you go for something bigger like we have done here, the Spider 3 Pro or the Dragon High Flow, right? Both are really solid options, no problem. The extrusion, is the palm gears that are in this printer right now are working just fine. So while you could at some point want to upgrade them, I don't see a need for it, especially if it's a printer that you print for building and not that you build for the building's sake and not for the printing sake, and if you're an intermediate to expert anyways. The same goes for the PTF YouTube. You're gonna replace it anyways, and that upgraded Z motor I can definitely see as a boon. So what we're left with between the old and the new r1.1 kit is the new catalyst board with the new toolhead board, which, to be honest, the old one with an EBP36 and CAN bus just fine, and the Z motor. Well, actually the only real improvement here that if we cared would be significant is the Z motor and the rails. Everything else, not so much. There was also supposed to be, I think, and let me check this real quick. I think there was supposed to be a Nevermore included in this kit. And for that, I would seriously suggest to abstain. Do not build or do not pay for the Fysetc Nevermore kit. It is, especially with the hardware you still have left in these kits, there's enough hardware that you can build the Nevermore without needing anything else. You may need some Wagos, but you can get away without them. The only thing you really need for Nevermore are those two 5015 blowers. And for those, you're going to buy really good quality Sunons anyways, because they are the only ones that are reliably capable of pushing the air through the charcoal, through the activated carbon, that at any kind of a circulation and speed, which is really important, because if you can't push air, if your fans are not able to push air through those, then you're not going to get a good filter effect. I tried this before. I had the Nevermore running on Fysetc fans in the Trident, and it did zero. It like there was barely any airflow noticeable, and the result of that is not only does it not cause the convection that you want, where you're pulling cold air from the bottom and pushing it to the top to get a better consistent heating across the whole chamber, you're also not getting the filter effect you want to keep yourself safe. So you do not build on those. So my personal verdict would be to, if you have a chance to pick up a R1 kit cheaply, do not buy the R1.1. Buy the R1 kit. If you can get the R1.1 to about a $50 extra range, like $50 more expensive than the R1 kit, that's when I would start looking at the R1.1. That's where I would basically say, okay, now we're getting somewhere where it's worth it. But that only goes for intermediate and expert builders that want to build for the building's sake. If you want to build this to get a purely reliable printer, the Trident kits from Fysetc are less problematic. They are also easier to mod and fix once you have them built. And if you really want to do yourself a favor, just go with an LDO Trident kit to begin with. I know it's expensive. I know it's much more expensive than even getting a Fysetc Trident kit and then modding it to be as reliable. But for your first printer builds, I suggest going with an LDO kit. yeah, so that's basically my verdict on this. You already heard the update recommendations here, and let's maybe in the meantime also go to the slicer and do something else, because our retractions print is done, and I'm going to print max flow rate next. We don't want to save that, and we want to actually we want to do a retractions test first. Let's do pressure advance, then retraction. And actually, no, we're not going to do pressure advance, to be honest. Don't think it's worth it. Pressure advance should be reasonably well set up now. Oh, and retractors we already did. So let's just look at the max flow rate. And we're going to expect that we can at least do 15, and we want to go to 35 in steps of 1. Gonna slice that. That's definitely going over. So we're going to go back here, set the skirt loops to 0. This asks us if we want to enable spiral, and whoops. I'm gonna slice that. Now it's really important, as we noted before, to check what's going on here. Whether this is actually working properly. And if you check that out, that is not looking like a proper flow test. And that is because we changed the vase mode flag after the fact, after we created this. So the correct way of setting this up would actually be to set vase mode first before setting this up. There are additional settings we should check at least, which are in the motion ability. And that looks fine. And in the material, there we go. That sets the ASA to 200. Check real quick whether we set this up and whether we set the object up properly. That is the ASA. It is set to 250 for the extrusion, 110 on the bed. The cooling, okay. And if we slice that now, what we want to see is a proper gradient in flow and speed, which we're still not seeing. That is driving me nuts. So let's try this again. And by the way, you need to try this until you are satisfied with how your print works, looks. going to discard the old values and generate this again. Slice that. Not the filament. And here you see that we have actual proper gradients. The same we want to see on the flow, and only if it looks this way is it going to be a proper print. Otherwise the other prints would have been wastes of filament and failures, so only this is going to do what we want. The problem with this print is that it still has a prim enabled, so we disabled that. The gradient is still there for the flow, and the speed, we're still in race mode. So this is now a proper setup. There seem to be a couple bugs that result in these prints not being set up properly and the G-code being destroyed when you fiddle with the settings and use the wrong options. I have yet to completely figure out how this is supposed to work, but it's getting there. It's getting there. At the very least, I know that we need to be careful in how these gradients look, and only if they look proper should we start the print. Okay, since we started the print, one thing we should definitely talk about is recommended upgrades. The recommended upgrades I would do to this kit, as already mentioned, is put an ABB36 on this, move this to CAN bus. It's something we are going to do. That also allows us to then use some proper LEDs with short cabling on the tool head. So that's a really good change. I seriously suggest doing the security upgrades or the safety upgrades in terms of the ring terminals and the earth connection. Upgrading the fans you can do later. With the EBB36 you have all the flexibility, and that's basically it. If you do those, you should get a reasonably dependable printer. That's all it takes for now, and if you follow all the gotchas I mentioned earlier, you should end up with something useful. Yeah. It even looks like this printer is reliable at higher temperatures. So I'm quite surprised and excited that we didn't run into any problems with heat dissipation yet. So yeah, stoked on that. But enough about me waffling on here for too long. Let me know what you think. Let me know if you think I'm wrong here, if I should reconsider some things. If I haven't looked at a factor properly, let me know if this was a fair review, if this was a fair assessment. Because obviously I'm human. I can make mistakes. I can overlook things. I can overlook factors. And I do want to be as fair as possible to these products, since I'm using them myself. And especially with the Trident being my first printer, it went fine. It will not go fine for everybody, but it went fine for me. And it's really out of my wheelhouse to do these usually. It's something that's a bit out of my comfort zone. So I'm even somewhat proud of me that I managed to build 2 of these. And there's another 2 coming. If you haven't followed this, there's another Voron type printer with coming. That's a salad fork, and there is also a NXK3 build coming. That for both I'm really excited about. I gotta tell you, I'm really looking forward to both. The salad fork, the bubblegum colored salad fork will be really insane. The NXK3, I haven't decided on the color scheme yet. I don't want to reuse colors I already have, so a blue orange is out of the question, a teal yellow is out of the question, and a bubblegum pink blue is out of the question. So let me know what you think. Put it in the comments. Let me know whether you think I should go with, for example, my next choice would be green purple. Really solid choice, although a bit, I'd say, uneventful. That's my main problem with that color combination, is that it is so oh, our print failed. Interesting. Yeah, that color combination, the major issue I have with it is that it's so muted. I'd actually want to use colors that are less serious, less stylistically correct, I would say. But who knows? Maybe we're just going to. Maybe we are just going to. Okay, I am going to remove this again. And then I'm going to generate it again. And we're going to discard the old settings. We're going to kill the print, say yes to the thing here, and let's try it again. These being printer or rather slicer problems, though. They're not problems of the printer itself, it's how the slicer generates these flow rate tests. So I wouldn't hold it against this printer. Yeah, but in general, let me know what you think in the comments. Put me a line in the comments, let me know what you think. I'm always interested, more so obviously about the printer builds I will do later, but with all the things I mentioned, I think it's pretty fair to say, hey, this printer is potentially not for everyone. It can be pretty good. It can be pretty good if you take a lot of care in building it, and if you look at how much care I took with printing it, Like that's the reason why it turned out so good. In the end, especially if you're not a complete noob and you're not relying solely on the instructions to get you to a properly working printer, right? If that's not a requirement, and you just want to build, this printer build went just fine. It does take more attention. It does take more attention. That's always going to be the case. But there are things that other printers also don't do. Like I think even the LDO kits use fork terminals, which is kind of sad. It's kind of unfortunate. I wish that wasn't the case, but yeah, it is what it is. Okay, and by the way, if you want to catch another stream, and I think next week we will actually start going into modding this printer as part of the stream. Usually we stream Saturdays from 7 Central Europe time to 4 hours-ish, maybe 5, maybe 9. Sometimes I stream even longer. It kind of depends on what I want to achieve, where I want to be after the stream. So no guarantees on us finishing early. By the way, that looks better. Yeah, that's working now. Today is actually a bit of an edge case where I wasn't able to stream yesterday for ISP issues reasons. So I was kind of blocked on getting the stream to work yesterday at all. Even the stream today is showing a few problems with the stream quality. I really hope that that doesn't influence the VOD later, but we'll just have to see. Yeah, but usually Saturdays, 7 p.m. European time, 6 p.m. UK, 1 p.m. East Coast, or 9 a.m. West Coast if you want to join. You can let me know everything you want to tell me then. Again, with the first upgrades coming for this printer next week, using the EBB36, or I think I'm actually going to go with an SHT36 in case you're interested, and using the Catalyst board still. Then we're going to test that real quick, see if that works, set it up so it works, see if that holds out in the additional heat, and then move on to also placing a, I think, Manta MP4 in this printer. So we get some more customizability, so we can do a few more things, including at some point moving it to 36 volts. But yeah, the reason why we want to do the MP4 is mainly for what I already described. I want to run a proper open source OS on this. I need to be able to trust it, to hook it up to my network directly, to be able to secure it without having some mechanism potentially interfere with that. So yeah, that's the major goal. Getting some LEDs in there is a nice side effect. We do need to reprint the front of this because there are a couple of issues with it. But yeah, otherwise, upgrades coming. So next week we're also going to go into CAN bus. and how CAN bus works, what to look out for, how to configure it, where to get your data, right? Because those are a couple of problems, like how do I actually set it up? Where do I get the pin assignments for my CAN bus? How do I set up bridging? We're going to go into all of that. And then we're gonna mod the hell out of this printer until we consider it safe and stable. Obviously only as long as we don't receive the Annex K3 yet, because that's why we're stretching this a bit. That's why we're going into the mods next week, is because I am expecting to get the Annex K3 in sometime around the end of April, and it basically makes no sense to start anything else beforehand. As far as other projects go, you remember I had the Z13 project that would allow me to mount controllers on the Z13. I am sad to say that that project is for the moment on pause. The reason being, maybe I can show you that for some laughs in between. I got myself a Lenovo Legion Go as a gaming handheld. So while I would still love to have controllers attached to the Z13, this is a smaller tablet that I can actually use to play games. I've been playing Diablo on it for a bit, and I have very much enjoyed Horizon Zero Dawn on it. Both games are really fun. There are a couple of other games that I am definitely going to pick up again, looking at you Cyberpunk and The Witcher, but this thing for the moment, my main driver. I got this because I thought I might even be able to use these controllers and build mounts on the Z13, because the controllers I got originally, you may remember these, and them being that you can actually take these apart here. I thought these would work. The problem is that I can, for the life of me, not get them to be compatible with any of the Joy-Con utilities. These are Joy-Cons, and they're seemingly not compatible with any of the Joy-Con utilities that are available at the moment, which means that I can't get these controllers to reliably and properly emulate an Xbox controller, and because that's the case, they're basically useless. So that's the reason why the project's on hold. If I figure out how to get these to actually emulate an Xbox controller, I will continue that project. If I figure out how to mount these on the Z13 without causing mounting issues, like let me show you this quick. There are a couple of issues to look out for that we don't have with the other controllers. So if we, for example, take these, we put them on the side here. We still need some way of having the sound come up, because the sound's actually here and up here, right? But we could, in theory, we could just cover the lower ones to some extent. Actually, it wouldn't even be. Never mind. It sounds only here. I think some is also in other places, but this is actually on the wrong way around. The point being, if we mount the controllers this way, we don't abstract the volume buttons. We don't abstract the at least one of the USB ports. Sure, we will need to figure something out for the speakers, but that's a minor concern. We can do that in CAD. But from a size perspective, these would work. Now, as I already said, I was thinking maybe I can misuse the Legion Ghost controllers to do the same thing, because these, because they're from the Legion Go, are capable of emulating an Xbox controller. Putting them here would work. The problem is they obscure the volume buttons. They obscure all the USB ports, and that's not good. So yeah, that's basically the KO criteria for these. Can't have that. Can't have that. Doesn't work for me. Doesn't work for me. But yeah, this thing has been fun. I haven't had time to play it a lot, but it's enough. It's enough so I can at least have some fun, have somewhat of a good time with it, and I don't mind it. It in itself actually had a pretty cool project in that I had to replace the SSD. I bought the 512 gig version and then had to replace the SSD with a 2 terabyte one. Because, and this is also something very interesting I found, if you're also into VR in some way, this thing can play Half-Life Alyx on the lowest settings, but it can play it. That's amazing. That is properly amazing. Yeah, anyways, so toys. Toys. No, I don't like that. I don't like that. Yeah, those are the concerns I have, but yeah. We'll see. We'll see. I would really love to continue that project at some point. Not sure when. In the meantime, let's have a look at this. And the very surprising fact is that there are no rips in this, and I think this is just about the most consistent print I've seen from this printer yet. Okay, we can see, and I will show you in a minute, we can see some artifacts. Oh, wait. Something to check here. First. So we can see some artifacts on the top layers. They are very faint, but if you check this corner here, for example, let me see if I can. There you go. See this? The top couple of layers here do show some artifacts, and I would already consider that a fail in flow. It's not significant, but it is a fail in flow, and at 35 cubic millimeters per second, that's just about where I would expect it. So yeah, good job, little printer. but that's definitely a hard limit. Now, the question isn't where is the hard limit, but where is the soft limit? Where does the printer not extrude enough material anymore to keep the requested volume? And that we can only figure out by, again, using some calipers and cutting into the print. So, as always, I'm going to assume that the bottom here, the bottom couple of layers are printed properly and with full volume. And I'm going to measure, well, actually, the way of doing that would probably be more to the end of the print. So let's take these off completely. And yes, layer adhesion, while pretty good with this ABS stuff, I think the layer adhesion or the resistance was actually better. The stiffness was actually better on the PLA stuff, but no matter. I'm going to switch to this view, and now we're going to take this. This is 0.47. This is on the top is 0.42, 0.41. The question is, how far do we need to go up to get a proper result? And I think we can still get away with this. So here's the problem. Here's why this was a mistake. It's because we would have needed to measure from the bottom, but we can also just measure how much we took off. And we are going to measure how far we took this off on this side, because we took off 4.9 millimeters, 4.94, and we are seeing the artifacts about there. That's another 12.45. So let's say 12.5 millimeters plus the 5, that's 17.5 millimeters. So that is 15 plus 17.5 is about 32.5 millimeters or millimeters square in flow, because we have 1 millimeter square per millimeter in height. So 32, the theoretical max, that pretty much matches the what we had with PLA. Well, actually the absolute height is probably more like 34, 45. So to get absolutely consistent results, we could go with something around the 28 to 30 millimeters square cubed in flow rate to get consistent results. Cool. So that's that. We printed with ABS for about 2 hours-ish now, including letting the printer soak and cool down and get up. So from that point of view, from the reliability point of view, I am really satisfied with that already. I will see if I can push this some more to update on the long-term viability of the printer. But for now, I see no issues whatsoever with printing higher temp materials. The controller board stayed cool, the connectors are all connected. We had no issues with disconnects whatsoever. All the cables are still working as it seems. So yeah, pretty much satisfied. Very, very satisfied with how that turned out. The sensorless homing adjustments should fix our reliability problems as well. So yeah, pretty good. Pretty slow stream, but still very good. I think we're going to call it for the day. I think it's enough. Tomorrow is a work day anyway, so probably a good thing to do. Probably a good thing to do. Yeah, let me know what you think. Let me know what you think about the review, about how I approached the review as well. Please keep in mind that this is meant to be a full list of what I discovered and what my verdict would be. If you have a chance of picking one of these printers up yourself and you get it really cheaply, feel free. It's a lot of fun to build. Look for the pricing though and make up your mind based on that, whether it's even worth getting the r1.1 kit, because the r1 kit is already very solid, and if you're planning to upgrade a bunch of parts anyways, you might not need the ones that Fysetc upgraded. That being the concepts here. Yeah, if you want to catch a stream, 7 p.m. Europe on Saturdays usually, not Sundays like today. 6 p.m. UK, 1 p.m. East Coast, 9 a.m. West Coast. Drop me a comment what you think. Drop me a like, share this, subscribe, and I would very much like to see you in one of my streams. Until then, thanks for watching and thanks for playing.